Give the most descriptive name to the figure formed by connecting consecutive midpoints of each of the following quadrilaterals. Be prepared to defend your answer in each case. Use a sketch to problem solve. We could draw them, but then we're not nearly as certain as if we construct them. But for grins and giggles, I'll start off by trying to draw it. So if I guess that's the center of the circle, then I know all radii of a circle are congruent. Let me connect those points, because I know that the diagonals of a kite, which a rhombus has all the properties of a kite, the diagonals will be perpendicular. So now if I draw or estimate the midpoints of each side and join them, is that a quadrilateral, or is that something, or is there a better name for it? And the drawing isn't working out so well, which is why I'm making the video. It would be ideal if we did more constructions in the class. When you open it up, it starts up on the translation arrow or the selection tool. And we know that a rhombus, by definition, is a parallelogram with consecutive sides congruent. So to start that, I'm going to focus on the consecutive sides congruent. I know that all radii of a circle are congruent, so I'm going to start with a circle. And now I need to draw a parallelogram, which means that opposite sides are parallel. Well, given a line and a point knot on it, there is one and only one parallel line. Given a line and a point knot on it, there is one and only one parallel line. That point of intersection is going to be the vertex that I need. So now there's my rhombus. So I'm going to hide everything else. And now I need the midpoints. So I'm going to construct the midpoints, and then it said to join consecutive sides. And to do that, I'm constructing a segment, which is Control L. Any 2 points determine a segment, so that's what I'm using. So now this central figure is the one that I'm most interested in. And the nice thing about the dynamic geometry software is that no matter where I drag any of the points, if I've actually constructed it, the quadrilateral will retain its shape. Now this is an interesting figure. And if we measure the lengths of the opposite sides, what do we notice? Should probably pick this up and move it a little bit. What about that angle there? What do we notice about that? So what shape is that? In 5.4, our definition of a kite was a quadrilateral in which 2 disjoint pairs of consecutive sides are congruent. Now, I do believe that there's easier ways to construct a kite, but I'm going to go with the book's definition. So I'm just going to construct a random segment there. And I need consecutive sides to be congruent, so I'm going to use a circle. And the reason why I constructed that segment is because I want to create this radius specifically, and then select a random point on that segment, and then the other midpoint, the other endpoint, which wasn't in our circle, and that to construct another circle. So now these intersection points when I join these 4 points, Control L, there's my kite. So now I'm going to hide everything else that I don't need. And now I want the midpoints, Control M. So now let's measure these lengths. And what do you observe? Let's measure an angle to see if we observe anything there. And so now with the dynamic geometry, I should be able, let me show all hidden. This is the point that I need to move. So let me make one visual modification. There we go. It'll be a little easier to see the numbers then. So no matter what I do to this kite now, what shape is formed when we join the midpoints, consecutive midpoints? So the next one on our list was a square. I'm going to go back to the circle for this because I know that a square is a parallelogram. That is a rectangle, so it has a right angle, but it's also a kite in which consecutive sides are congruent. So let me construct a perpendicular line there, grab that intersection point, and then I want a parallel line, so given the line and a point not on it, construct a parallel line and repeat that. And I need that point of intersection. So now, those are the sides of my parallelogram, and I'm going to make those more visible. I'm going to construct the midpoints and then those segments. So let's measure those. And let's take a, is that a rhombus or is that a square? Let's take a look at the measure of an angle. And will that always, always, always be true? Start with our initial point. So with the dynamic software, I've constructed the perpendicular so that will always stay there. So no matter where I drag the points around, you can see that that will always be a square. That AB, and it didn't name those 2 points, but the initial figure that I created is always going to be a square. So now what shape is CDEF? Now let's take a look at a rectangle. So in our book, on page 236, the definition of a rectangle is a parallelogram with a right angle. So let me start by just some random segment. I'm going to focus on the right angle first. Given a line and a point not on it, there's one and only one parallel line. And then I'm just going to construct a random point on that line and construct a perpendicular. Now here's the tricky part. I need the parallelogram part. So I need to join the right point here, the correct point on that segment. I'm not sure that you could see the icon in the video, but we'll find out. So I want a parallel line there. So now I need that point of intersection. And just going to construct it because I'm never really certain when I click if I'm getting the exact intersection. This way, if I let the computer do it, I know it's all correct. So let me just thin those out and now go for the exact sides of my rectangle and make those more visible and measure. And now, oh, I shouldn't have let go. Construct the midpoints, join those, measure those. So these are the sides we're looking at now. And it doesn't even look like there's a right angle in there. So I'm not going to measure that. Can we make an inference about what shape is formed EFGH? What shape is that? Now there it looks like it could be a square, but does it always have to be a square? And the next one is any parallelogram. So I'm just going to make two random sides, apply the parallel postulate, oops, and now I have, come on, now I have my four sides. And I want to find their midpoints and join them. And this is the figure that I'm mostly interested in. What shape is that? ABCD, what shape is that? For an irregular quad, there is no construction involved. Just have to make sure I make a four-sided figure. Then the midpoints, join them, measure the lengths, and what shape is formed. Even if it's concave. Let me make ABCD a little solid here so it'll be a little easier to observe. There we go. So now, no matter where I move any of these corners, what shape do I have there? And then lastly, the Isosceles Trapezoid, which to me, the easiest to make, or easiest way to construct an Isosceles Trapezoid is to make an isosceles triangle. And already I have a circle arc congruent. And now I just want to construct a random point there, use the parallel postulate, and then that is my isosceles trapezoid. Make it a easy to see color. Now I need to find these. Actually, what I'm gonna, whoa, where'd it go? Just going to change the, there we go. And let's focus on the sides of our isosceles trap. And then our midpoints and the shapes and the shape that is formed when we join consecutive midpoints. And this time I'm going to make it a darker color so that it really jumps out. There we go. So now no matter where I move, we can see that that shape retains some properties. So let's measure those sides. Doesn't even look like we have any right angles in there, so I'm not going to measure those. But what shape is formed? If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.